Hello, Betty. So here is our the most important section of this week. That is what Super Six quiz. Six important questions from Newton's laws of motion chapter. Right. Give yourself 20 minutes to solve these 20. Oh, sorry, to solve these six questions. Right. So all those questions I will show you one by one. You can pause your screen at these positions. Like that is question number one. Then question number two, you can pause video here. Question number two. Question number three, pause video here. Question number four. Question number five. And question number six. Block over block problem. Right? As suggested by my very good student. So now these are six questions. Right, beta? So try to solve all these six questions. Given time is 20 minutes. Last time when I posted Super 6 section, then one of my students said, Sir, out of these six questions, two questions came in our VAT exam, right? So all the questions that I'm sharing are very, very important questions, right? So these questions must come in some of your exams. It can be like VAT, CAT, RAT, right? So if in these exams these questions are not coming, then you should feel very happy because these questions then can come in actual JE advance, right? So all are very important questions, beta, right? That is what only I want to say, right? Nothing else. Okay, so let's quickly see the answer key, right? Do the self assessment, see how much marks you are getting. Okay, see beta. First D option, second ABD, third 3G by 4 meter per second square, fourth 5 kg, fifth 2 meter per second, and sixth is match the column. A match with R, B with R, C with the QR, D with the PQR. Okay. So dear students, now question number one. So question number one, obviously it is based on wedge constraint, right? So the total solution I am showing you, right? So based on what beta? Wedge constraint and brainstorming angle should be, we should try to find horizontal and vertical components of velocity of sphere, right? So wedge constant, we know if any two rigid bodies are in contact, then there cannot be any relative motion in a direction normal to the contact surface. So perpendicular to contact surface, there cannot be any relative motion. That is what beta? Wedge constraint. Okay. So now here, if you see left wedge is in motion, right? And sphere on it is moving, means velocity of sphere can be along the surface of wedge 1 only, right? So that is our crux point. Okay, the velocity of sphere with respect to wedge 1 should be along surface of wedge 1, right? So it's not like with respect to ground it is at an angle of 30 degree with horizontal, but with respect to wedge 1 it is at an angle of 30 degree with respect to surface. Right? That is the very important point of this question. Okay. So now horizontal component of sphere must be equal to horizontal component of wedge 2 because their contact surface is vertical, perpendicular to vertical direction, that is a horizontal direction. In horizontal direction there should not be any relative motion. That's it, right? So horizontal component is what? 2u only. Vertical component only we need to find out, right? So by our crux point, so velocity of sphere with respect to wedge 1 I am writing. Okay, so this vector form I am getting, so 3u I cap and vertical component. Okay, so and now this vector must be at an angle of 30 degree with horizontal because this vector is representing velocity of sphere with respect to wedge 1, right beta? Okay, so then by this equation I am getting vertical component also. Then net velocity of sphere is a horizontal component whole square plus vertical component whole square. So net velocity of sphere we are getting root 7 into u. Okay, that is question number 1. Right, so if any point is not clear, please write in the comment section beta. Okay, now question number 2. So question number 2 again, so it is looking a very easy question, right? It is just based on the nature of a friction, right? So what is the nature of friction? When friction between any two surfaces is kinetic, when that friction is static, right? So all about that. Okay, so approach is very simple, nature of friction. So now here man is walking on plank. So what it means? It means the nature of friction between man and plank must be static, right? So there should be static friction between man and plank because they are saying man is walking, right? So frictional force on man is ma backwards, or due to man is ma backward on plank, right? So because the man is ascending in forward direction, it must experience force in forward direction, right? And the same equivalent opposite pair on plank, force exerted by man should be ma in backward direction, right? So now when it comes to about option a, the maximum force that can be applied, right? So ma is acting in the backward direction, right? So then if you are applying force F in the forward direction, that applied force exceeds from ma, so then friction from the lower surface will try to counter it, will try to balance it, right beta? So you are increasing this F force, it is more than ma, so then the friction from the ground will come in action, right? So this will increase, this will increase. So how much maximum force you can apply? The maximum force you can apply is this ma plus the limiting value of friction from the ground. So that is the maximum force you can apply. Now B option is a very tricky option beta. Now here in this question, the possible options we have to select. So is what can be the correct possible option. Now if here no relation of ma is given with this mu into m plus small m into g, so that is limiting value. So that's why I'm writing each and every step that if ma is less than fl, right, from the ground, limiting friction, if it is less, it means that f is not required at all, right? So means we do not require this F force to keep the body to keep the plank at rest. But if MA is more than limiting friction from ground, then we require a minimum force, right? So then your FBD of the plank will be like this. So MA on the plank is acting on left direction. Because of this force, the friction will try to balance it, will try to oppose it. So friction is acting in the forward direction. Now if MA is more than this limiting value, so the remaining force you have to provide to keep the body at rest. Okay, Betty? Right. So that minimum force will be this quantity. So now from A and B, clearly we can see beta, so that the friction direction is changing, right? So C is clear. So now since the man is accelerating, its kinetic energy is increasing. So you can say D is also the correct option. Means mechanical energy of the system is increasing. Okay. Now let's come to question number 3. Question number 3, very important question. Okay. Yes, so this system is there. Now in this system, that is infinite pulley arrangement system. Now approach must be constant relation only, because whenever it comes to string, pulley, mass system, then always we apply power method. So from power method we can first write, so that net power associated with this system must be 0, that we are writing. Now system is starting from rest, right? So derivative of velocity will be what? Acceleration. So that same relation you are writing for acceleration also. So we are getting this kinematic constraint associated with the acceleration of different blocks. Okay. Now let's substitute the value of acceleration of individual masses, T minus mg upon m T by 2 minus 2 mg upon 4m, right? Okay, right. So this I'm writing. Now I'm separating the terms, tension terms and this G terms I'm separating, right? So it's just about calculation, not much in this question. Okay. So what we are following beta? Here we are getting an infinite GP on left side, and on right side also we are getting an infinite GP, right? So we are getting value of tension T as 7 mg by 4 on calculation. Means here tension we are getting. So this tension we are getting for 7 mg by 4. Okay. So it means acceleration is 7 mg by 4 minus mg divided by m. So you are getting 3g by 4. So that is the acceleration. Okay. So there are other methods also for this question available in the market. Okay. So but that is the origin beta. So whenever we have any infinite system, so we can apply constant relation like this. Okay. Now let's come to question number 4. So question number 4, again some part of string is there, right? And mass of a portion of string is required. Mass of portion AP is required. So obviously here approach should be, we need to select some element for writing force equation, right? So now brainstorming angle for this question should be that how we can relate a weight of rope with the common forces at different points. So means what I'm trying to say, common forces at different points. So at different points, like here we have tension T1, so then here also tension should be T1 like that. Okay. Now, if tension here is not T1 beta, then what will happen? Horizontal component of forces on this system will not balance because angles are 30 degree. So here you are writing some T2. So T1 cos 30 is equal to T2 cos 30. So automatically you will get T1 is equal to T2 or T3 here, right? At this point I'm saying, right? So that's why I'm not writing anything here, right? So obviously by symmetry, mass of this left part should be equal to mass of right part because tensions are equal. So vertical components of tension should be balanced by weight of this section, right? Here at the horizontal point, tension is horizontal only, na? So vertical weight should be balanced by vertical component of tension here only. Similarly, weight this side should be balanced by vertical component of tension here, right? So it means masses of these two elements should also be same. So mx, my, mx, and the required mass I am writing as my. Okay, beta. So that is the one thing, that these two masses should be equal, right? And the mass of the required section AP I am writing my. Now I am working with the force equation, right? So horizontal force balance, so T2 is equal to T1 into root 3, and then vertical force, total mass, first of all we know this is total mass, and vertical force balance separately on you're writing for right part T1 sine 30 is equal to mxg, right? And separately you're writing on left part means this whole left part. So on this left part you're writing vertical force balance, so mx plus my into g. So T2 you're getting. Now this T1 and T2 values will substitute here in this equation, right? And also we have one equation 2mx plus my is equal to 10, and I am solving this equation. So, and what I am getting beta, my is equal to 5 kg, right? So that is our question number 4. Now question number 5. Now question number 5 is very again looking difficult but an easy question, right? So laws of motion we have to write, right? So we have to write laws of motion equations on 60 kg mass or 40 kg mass, right? Now here system is released from rest. So it is a kind of block over block problem, right? So block is a 40 kg and that is a 60 kg. Now 60 kg is placed on some this, what is that, belt. Okay, so belt is massless. So now there is a tendency that there can be relative motion between a 60 kg mass and belt. That is possible, right? Or it is also possible that there is no relative motion. If there is no relative motion, it means the magnitude of acceleration of 40 kg and 60 kg will be same. So then what should be the brainstorming angle for these kind of questions? We first assume a common acceleration of the system and study any one body with respect to common frame. So that is how we approach block over block problems, right? So now first what I am doing, I am assuming some common acceleration. I am assuming there is no relative motion between B and the belt. So then net pulling force divided by total mass of the system, I am getting common acceleration as 1 meter per second square. Right? So now after that I can analyze the motion of B with respect to common frame. So if I am studying B with respect to belt, say, so pseudo force on it is 60 into 1. So now it should be less than what? The limiting fraction. If it is more than limiting fraction, then there will be relative motion. That is how you check whether there will be relative motion between two surfaces or not. Now limiting friction is what? 300 Newton we are getting. So much higher than the pseudo force. It means the assumed acceleration that we had calculated is 100% correct. So it means B will not slip on the belt. Okay. So their common acceleration is 1 meter per second square. Now problem became very, very easy. Right. So normal velocity is under 2 as. Displacement covered is 2 meter. Okay. So we are getting 2 meter per second. Right. Okay. Now question number 6. Block over block problems. So as I said, bete, for block over block problems, now here 3 blocks are shown. So what I will do, first step 1 is I will assume one common acceleration, just like I was explaining in previous question. And step 2 will be I will study different blocks with respect to common frame, right? And friction should be less than limiting value for no relative motion. Means any individually any block I am studying, so on it whatever the other forces are acting, their resultant should be less than the limiting value. Otherwise there will be relative motion, right? That is how to check. So now in this question relative motion only they are asking. So first of all, limiting values we can write for each and every surface separately. So limiting value of for surface 1 is 8 Newton, 0.4 into 2 into G means 8 Newton, right? Similarly, limiting value between 3 and 5, surface 2, it is 15 Newton. Limiting value between 5 and ground, that is what? 10 Newton, right? So again, I'm assuming common acceleration to start my problem. So assumed common acceleration is this, F minus 10 upon 10. Because F is different, right? So F is different in different columns, right? So F I'm taking as variable. Now substituting this value of F, I'm getting a common acceleration for different cases A, B, C and D. Now I will check one by one all the cases. So in detail I will explain, beta, right? So very important question. Okay. So for all options, first of all, we can see there is a relative motion with respect to ground. From ground, limiting value is very less. If I'm taking A, B and C as a system, what we are finding, the applied force in all cases is more than the limiting fraction from ground, right? So for all option, relative motion with ground will be there. First of all, this thing. Now, for A option separately, we are doing study block A with respect to common frame. So I am studying block A with respect to common frame. Pseudo force acting, because the only force acting on 2 kg with respect to common frame is a pseudo force, because actually there is no force acting, right? So only pseudo force is acting and friction has to overcome, has to balance or has to counter pseudo force. Now pseudo force is 0.6 Newton and limiting value here is 8 Newton. So it means no relative motion, right? Now here I cannot surely say that there is no relative motion. I need to check whether there is a relative motion between B and C. So if there is a relative motion between B and C, so then we'll get a new value of common acceleration of A and B, and then again we need to come back to block A, right? That whether relative motion is there or not. Okay, Betty? That each and everything, whatever I am saying, I have written also. I will explain. So now here I am saying let's study combination of A and B. So if I am treating A and B as one block, so the net force acting on it is what, beta? For A option I am doing, so it is 11.5 Newton. Again that is less than limiting value of surface 2, which was what, 15 Newton. So it is less. So it means no relative motion between B and C also, right? So it means our first assumption is correct. So all the three blocks will move together, right? And their common acceleration is what we had calculated, 0.3 meter per second square, right? So now if we are looking at the option, relative motion between A and B is there? No. Relative motion between B and C is there? No. Relative motion between C and ground is there? Yes, so it is there. So A is matched with R, right? Relative motion is not there at N. No, that is wrong then, right? So A is matched by R. Now similarly, exactly same procedure for B option. So now the numbers are such that for B option also same thing will happen, beta. The things will change for C option. So C option I'm discussing, and then again D option will be very interesting. So for C option, AC is 1.5. Study of block A with respect to common frame, just like what we did in A option. So here we can say it is no relative motion, but not surely we can say. Again we need to cross verify, right? So now in second step I am checking combination of A and B. So combination of A and B, net force is 17.5, which is greater than limiting value for surface 2. So relative motion will be there between B and C, right? So when we are getting relative motion between B and C, it means surface C will offer what friction, that we know, right? It means combined acceleration of A and B we can find, right? So if A and B are moving together, then their common acceleration should be 2 meter per second square. Now checking motion of A with respect to B. Now I am cross verifying it, that between B and C there is a relative motion, and A and B, if they are moving together, with what acceleration they should move. So they should move with 2 meter per second square. Now pseudo force on A with respect to B. Now A I am studying with respect to B. So that force, pseudo force is 4 Newton, and again it is less than limiting value. So hence no relative motion between A and B. So I have cross verified it. So between A and B there is no relative motion, and B and C there is a relative motion. Okay. For C option only Q and R are correct. Now similar thing I am doing for D option. Again it's an interesting option, beta. So for D option, common acceleration I am getting what, 3 meter per second square. So study of A only with respect to common frame. See, it is 6 Newton. So again we will verify. Yes, we will verify again. So 6 Newton, which is less than limiting value. So from here, what idea we are getting? We are thinking like there is no relative motion between A and B, right? So now I am checking A and B as one mass. Net force is 25 Newton, greater than limiting value. So there will be relative motion between B and C. Now, if A and B are moving together, as the idea I am getting from here, that A and B are moving together, if they are moving together, then what is their common acceleration? So their common acceleration is what, beta? 5 meter per second square. Now, if they are moving with 5 meter per second square, then is the limiting value between A and B is sufficient to overcome the pseudo force? Let's check it. So checking for A with respect to B, pseudo force will be what? 2 into 5. Now it is coming more than limiting value at surface 1. Right, beta? So that is the crux point of this question. Okay. So there will be relative motion between A and B also. Right. So for D option, P, Q, and R, these options will be correct option. Okay, beta? So see each and everything in detail carefully. You see beta. All these six questions are very important question, right? You may find this question very easy, or you may also find very difficult, right? It's dependent on you. So, but if anything is not clear, please write in the comment section. Okay, don't hesitate, right? Okay. So okay then beta. Thank you very much. Thanks for watching.